Last week you worked with the Pythagorean theorem, got more practice with it, and with some word problems. And the Pythagorean theorem, if you recall, it applies to right triangles. If you have a right triangle, so if you have a right triangle, then a squared plus b squared equals c squared. And a and b in this case are the legs, and c is the hypotenuse. So that is our theorem. Now, in math, whenever we have a theorem, there's some times where we could change the order of the statement. We could reverse its order and it still remains true. This is not always the case, but in the case of the Pythagorean theorem, it is true. And we call that the converse because we are turning things around. So the converse of the Pythagorean theorem is me just taking my two statements and switching their order. So the converse of the Pythagorean theorem is if a squared plus b squared equals c squared, then you have a right triangle. Then you have a right triangle. And in this case, once again, a and b are just the legs of the triangle, and c is the third side, or the hypotenuse. Why we would want to bother to know this and use this is sometimes we will have a triangle described, but we don't quite know if it is actually a right triangle or if it is just some other type of triangle like a scalene triangle, etc. So if we take a look at problem 1 here, it says a triangle has sides of 16 centimeters, 34 centimeters, and 30 centimeters. Could these side lengths form a right triangle? So we want to decide if this triangle is in fact a right triangle. We're going to use the converse. We're going to substitute in our side lengths for the legs and hypotenuse and see if we get a valid statement. How we choose to substitute matters, though. If you recall from last week, the hypotenuse is always going to be the longest side of our right triangle. So when we are substituting in for A, B, and C, the first thing we want to ask ourselves is which measurement that is longest in our three measurements here. So when I read 16 centimeters, 34 centimeters, and 30 centimeters, 34 is the longest, so that is what I'm going to substitute for C. 34 for C. Which means my other two measurements of 16 and 30 are my legs. So I'm going to write 16 squared plus 30 squared. So if this statement is true, we have a right triangle. If 16 squared plus 30 squared is equal to 34 squared, we have a right triangle. If it is not equal, then we don't. So this is where we're going to pull up a calculator. We can just type this in. We could type in 16 squared plus 30 squared. And I get 1,156. And I'm going to compare that to 34 squared. So 34 squared is 1156. So those measurements match. So 16 squared plus 30 squared is 1156. So is 34 squared. So since that is true, yes. To answer my question, could these side lengths form a right triangle? Yes. 16, 30, and 34 form a right triangle. So I'm just using my same theorem for a different purpose. Instead of me knowing I have a right triangle and applying a squared plus b squared equals c squared, I'm flipping the order. I'm deciding if a squared plus b squared equals c squared, do I have a right triangle? So one more example of this, if we look at problem 2, a triangle has sides of 7, 18, and 19 centimeters. Is this triangle a right triangle? Once again, we first want to identify which of these sides would be our hypotenuse. That's going to be the longest measurement. In this case, it's 19. So when I'm right, a squared plus b squared equals c squared, I'm going to substitute in 19 for c. My other two measurements of 7 and 18, I'm going to substitute for my legs. So 7 squared plus 18 squared. And now I'm going to check this. I'm going to see if 7 squared plus 18 squared is the same thing as 19 squared. So I'm just going to type that in. Once again, I'm going to type in 7 squared plus 18 squared and I get 373. But if I compare that with 19 squared, I get 361. Oh no. What does that mean? We have 373 for 7 squared plus 18 squared, and that is not equal to 361, which is 19 squared. Well, what it means is that we don't have a right triangle. Since this is not true, is this triangle a right triangle? No. Nope. This triangle is not right. So it is not a right triangle. What this would mean is that we're talking about some sort of other triangle you've seen in mathematics days past. Maybe it's a scalene triangle that's obtuse, or maybe it's a scalene triangle that is acute. We don't know, but we do know with certainty that this is not a right triangle. So the converse of the Pythagorean theorem is just simply switching the order of our Pythagorean theorem. We are stating that if our shorter side length squared, the sum of our shorter side length squared equals the longest side length squared, then we have a right triangle.